you can see over here on the left side there that I have a power supply. Looks like a PC power supply. It is the ATX power supply from a computer case. And you can see that I've modified it to be the power supply for this whole system of other things that I have over here. You see a couple of fixtures there. The green one there is 2 fans, and then the white one off to the far left is also 2 fans. All of these are connected in parallel, all 4 of those fans. And then to the right of the green fixture, you see the light fixture, which has LEDs in it. And collectively, all of those devices draw 2.48 amps. And I was thinking for a while, they have the wiring and they're of the Molex connectors, because these things are fans, and they're meant to work with these power supplies. So why not use these? I have a whole bunch of these scrap power supplies, and actually that worked well for a while, but where I've been living now for a few years, it's actually outside, and wouldn't you know it, these PC power supplies are not spec'd to work outside. They get a bunch of dust in them, they get a bunch of dirt just blowing around, and they get in them and they just they stop working. So we're going to go ahead and design a completely replacement power supply for all of that. And then what we have here is 3 things. I have a long AC power cord. It's just two prongs here, because also what I have here is one of these 2-prong timers, and the timer is for, like, if you want to use it with Christmas lights, right? You can automate those off and on given specific time settings, and it's kind of a pain to set. I have a little printed booklet that tells me how to use this device, so that's not going to be a problem here. I'll be able to work it. And then also the power supply that it essentially controls on and off is right here. So this is a power supply that I ordered specifically online to be a 12-volt power supply with 2.5 amp output. So the 2.48 that it requires should be able to be provided just fine by precisely the amount that this provides. And you can see that it has a barrel connector on the end of it. Of course, that's going to come off, and essentially what we're going to attach to it is right here, that wire tail that attaches to the other ATX power supply at the moment. So we'll take that off and we'll bring it over onto here. But for now, what we want to devise is some way to sort of contain all of this, And essentially what I'm thinking is what we want to do is create perhaps some kind of like box over all of this, right? And then have a cutout rectangular space that sort of frames this right here, so we can still use all of that and yet have a box sort of over everything. And out the top, this power wire will come. The power for the devices here, maybe we'll have that come right out of the top along with that as well. So we want to make sure that we have some kind of way to make all of this, kind of protected, because this is outside, right? And that's what's been going on, breaking the other ones. We don't want anything else to get kind of gummed up. I suppose if we were super kind of quick and easy about all of it, what we could do is maybe like wrap a bunch of electrical tape around here and then around here, and then sort of like cocoon the whole thing in electrical tape, all around. That would look kind of irregular, and it probably will start to peel and, succumb to the weathering a bit and look kind of gross. So we're going to go with something a bit more permanent, and we're going to design a fixture, sort of like a hood, to go over all of this, okay? And the first thing that we're going to sort of figure out is essentially what is the footprint, right, of all of this. So the bottom right here, that's what we're going to define first. So I have my caliper here, I turn it on and make sure it's properly zeroed. And then I'm just going to take it like this and see kind of the general size of the footprint of this that we're talking about. So there we go. I'm going to say that much. That's 131 millimeters. Okay. Maybe it needs a little bit less. 127. Okay. So 127 by what? Another 127? Can we just make it a square? Right? Sounds good. All right. So we start on our plane here. We're going to start with a sketch on that plane. I think that's going through. Come on, Fusion. I've got Fusion 360 open here for you guys to do this modeling. So sketch, I'm going to do not a center diameter circle, excuse me, so this plane right here, okay, no, not a circle, excuse me, we want a rectangle, a center point rectangle, so there, that's going to be 127 by 127, okay, so that's sort of just the inside space of this, okay, and we're going to go ahead and give it the wall thickness that it needs, right? But we also want to make sure that any kind of lip that we also create that. I'm gonna show you what I mean by that in just a minute. Actually, you know what? What kind of lip do I want all the way around? Maybe like 5 millimeters. So wall thickness of 3 and then 5. That's going to put my concentric rectangle at 135, right? So out from here, we want 135, 135, right? Okay. And then what we do is we click Finish Sketch down there, and with said sketch, we extrude this feature. That's going to go up 3 millimeters, okay? And then we're going to start a new sketch on this surface, okay? We're going to start with another rectangle, center rectangle again. Whoop. Excuse me. So with this center rectangle, we start in the middle here. We go out to there. And then we're also going to use the offset tool here on the rectangle we just made. And we're going to come out 3 millimeters for wall thickness. But we're going to go the other direction. It's going to be minus 3 millimeters. It's not much of a lip. Uh, 3 millimeters is kind of a thick wall. Maybe we'll just do 2, huh? All right. Okay. And then what? Am I going to glue it down, or how am I going to attach it down? Do I want screws through this thing? You know what? Right? I think I do. So what we're going to do is we're going to set that wall thickness there for that one. Then we're going to go into our first sketch, actually edit that. And 135, this is going to be 142. And also this way is also going to be 142. Okay, so we have extra there. All right, that's a little bit better. Although we're not completely done because, excuse me, we wanted screw down points, huh? So edit sketch. Over here, we're going to sort of create with a circle tool a center circle right here, yeah. So there, this thing's going to be, say, 22. How big is that? What size are these screws that go through these, huh? Do we want to say they're probably like, as long as we give 5 millimeters. Okay, I mean that's huge, but we can put a washer on it if we need to. So 22 there, and then 5 here. Yeah. Right. So the same way all around. So from here, 22. Okay. And then also with the same tool again, 5. Okay. Down here as well. Right. And then again, 5. And finally at this corner, whoops, excuse me. Let's get that on there. 22. And then finally 5. Okay, so we finished this sketch. And you know what? I'm going to delete this sketch. And body. Let's see. I think if I delete this body, all I have is the sketch, right? Good. Okay. So let me re-extrude here. Where's my sketch? Right? Thank you. I'm going to unable to extrude. Let me go ahead and edit sketch and then finish sketch. It's invisible, huh? Oh, I see. Why was it invisible? I don't know. All right. So what we're going to select is just all of these, right? This is going to be the profile of our first extrusion right here. All of these pieces like this. We want that to be extruded by how much? 3 millimeters thickness. All of that, okay? That looks fine. Okay. Look at all that. That's sort of the profile of it. Now we'll do our wall thickness on this one. So new sketch with a center rectangle out to there, and then modify, offset what we just did, 3 millimeter thickness. Finish sketch. So this feature, how far do we pull this up? Huh? I mean, pretty high up, I think, right? That's just kind of an estimate, just to look at it. Excuse me, I didn't mean to lock that in. So there we go. That's what I'm trying to do. Sort of rotate the view there. So this segment, right? How high up does that need to be? So let's sort of figure that out, huh? Let's look at this that we've got here and sort of assess how high up that needs to be. Well, what I'm noticing is the height of it is related to, what's going on up here. So let's see, from the bottom, which is where just below the power supply, right, up to the top, all the way up. Okay, we're going to say that's 90. Yeah. It's pretty high up. So it goes up 90. That's the distance we need, 90. All right. So there's our thing so far. It kind of looks like this box sort of needs to come up to an opening at the top where this power cord comes out. So what I'm going to do for that is, first I want to model actually the face of this. Okay, and trying to make sure that I get a good, centering of this. So basically, what I notice is that the center line of this timer, right, is essentially the center line of also this right here, the power. So this is sort of going to be, centered there. So when I go to space the hole at the top relative to the opening on the front, I'll sort of remember that that's the case, right? So given that that's centered wherever that is, how wide is it? So let's look. We're going to say that it's given nice extra space, 62 wide. And then how tall is it? 62 wide by 28 tall. 62 by 28. So in the front face of this, we need a rectangle 62 by 28. Okay? Now where does that go precisely, right? So I'm going to say that a line in the middle of this should be a good start. And then how high up does that need to be? So we're going to start with a sketch on this face. And we create just a line. Sketch on this face. We do a line right through the middle. Just to sort of space this, right? Let me look. Come on. All right, so let's just escape from the line tool and look around a bit more. Did we bring that? We brought that all the way down to there. Okay, so that's in the middle of that. 28 by 62, we said. Okay. So 28 by 62. We're going to say that from the bottom of this up by 17. Okay. Then we're going to get our rectangle center right here. And then we get 28 by 62. Right? And where does the bottom of that go? Oh, it's still quite a bit lower. Okay, if I set this and then I adjust this by a little bit, it will raise that. Yeah? Good. Okay. So that's what I'm interested in it looks like from the bottom to the top there, looks like that's going to be about, what, 10 millimeters, huh? From the bottom. Is that the case? Yeah. Yeah, I think it is, actually. So we should have 10 millimeters from here to there. Okay. That's not the case, right? Measure from here to there. That's 5. Okay, so this needs to be 5 more. So escape from the tool there. That needs to be 5 more. 24. Right? All right. So that is the profile for the front of this. Finished sketch. We're going to extrude. Take this thing. Also the other half of that. And extrude. How did we extrude? Just cut it out. Here we go. All right. We have a window for our display. Okay. And then now what we want is kind of like a chimney, you know, for the wires to come out of. And I've got just the idea for that. So check this out, you guys. I'm going to use some pretty sweet techniques here. Let's grab this plane here. We're going to construct an offset plane, which is a pretty sweet tool. We're going to come up by, I guess 15 millimeters sounds good. And then on that offset plane, we're going to make a sketch. Okay? So our sketch is going to be a center diameter circle. And what is this? Basically, how big sort of a throat do these wires need to come out of? Looks like maybe like, we'll say 9 or 10. Just give it 10. Yeah, just give 10. All right, 10. Okay. Then a wall thickness of 3 as well, just like the other one is, I believe. Say 3 or did we say 2? Whatever. Okay. Well. Excuse me. Was that correct? So 10. And then I meant to use the offset tool. Excuse me. By 3. There we go. So there's that. How long does this sort of throat need to be as it comes up here? And even, well, that's actually not going to work because I can't thread the AC power cord through that in any way. So what do I do here? What if I cut the whole thing in half into 2 pieces? Right? All right. So, like, what if I do this, and then my advanced awesomeness loft? You guys ready for a sweet loft? That to there. No, come on. To there. Excuse me. Uh-oh. Alright. Let me cancel that. So let's try this again. We're going to do loft that surface to that surface, right? Can you do that? It's thinking. I think it's thinking. The loft cannot be created. Try changing the input, swapping profiles for rails or center lines, or tool body creation failed, it says. Well, that's unfortunate. I wonder why that is. Huh? Well, I guess I'm not using a fancy loft. And I guess this whole mechanism on the top is also gone. And as for our offset plane, do we need that? Yeah, I don't think so. Well, let me see. What can I do here? Well, maybe I'll just do sort of a few. But I want this to be able to come through. So how do I make this able to go through? Is what I'm thinking, actually. Let me see. Well, I guess I could just make it, like in a couple of pieces, right? All right. I've decided what I'm going to do. I'm going to go ahead and remove that offset plane. I'm going to create a new sketch right here on the top. We're going to get rectangles from there to there. And then we're also going to sort of put like a big rectangular space, right, that this piece can pass through. So it needs to be, say, 32 by 22. 32 by 22. So another rectangle, 32 by 22. And that's going to be like right in the middle of this, I guess, right? I guess we'll see, huh? 32 by 22. Maybe 22 by 32. Like that. Okay. And then our whole roof is just all of that. Right? So extrude this and also this by 3 millimeters. There we go. Fun, huh? So that'll enable the power cord to go down in there. And then this will also come out of the top as well. And we'll go ahead and model some kind of like, dome and then split into two. So it's like these two hemispheres that we can just sort of attach together and sort of set them on the top of this. And, or maybe not even, we'll sort of figure out what we want to do there. But I kind of like the idea of those pieces, actually. And I think I may just do them right now. So basically, is this piece done then? Right? It'll be able to screw down, be able to cover everything. I'll be able to get this in here. So basically what I'll do is I'll drop the power cord in through there, assemble it all, and then kind of glue around the edge of this so that this sticks to the face right here and that this is all in place. And then once that glue dries and it's all rigid in there and nice and stuck on, then I'll go ahead and get the whole fixture placed down onto the top of the roof there. And it will be able to be, a more permanent solution than what we presently have. So on top of here, okay, I think our piece is done here for now. So we're going to save as, or save, what are we saving? This is called Smart Litterbox Power Supply Case. It's a lot of words, huh? And this was 22 by 32. So basically, we're talking about like a circle that's like, let's do a new thing right there, and grab a new plane. So we're gonna draw a circle on this plane. Center diameter circle is 30. I'm gonna say 35. Okay. And then offset. Oh, those kids are running around outside, having a good old time. We're gonna say 50. Okay. And we're actually just gonna model this half of this, and then we're gonna duplicate it. Just do 2 copies of it. You'll see what I mean here in just a minute. So we cut this in half like this, right? We're going to go ahead and finish our sketch, and we're going to grab a extrude tool, take just this amount, up by 3, done. And then we're going to also do a new sketch. So on this, we have another center diameter circle. We come out to there, and then we come out to, there, which is 40. We're say 3 more than 35 is 38, obviously. But that only makes 1.5 millimeters around. I want another 3, so that's going to be 41. Whoop. What did I just specify there? We want to undo that circle. All right. Get our offset tool. That's fine, huh? Just 2 by 3. That's what we want. All right. And we want this to an offset plane and loft again. I think we can do it. So across here, finish sketch. We want extrude up by just a couple, 2 millimeters. Okay. And then we're going to do an offset plane, construct offset plane from here up by 25 even, huh? Right. So with this offset plane, we're going to create a sketch on here. Center diameter circle. And yeah, it's the same center. This was going to be 10, right? Modify, offset, 3, and finish. Wait, don't finish sketch. Bisect this with a line. Now we finish sketch. I think our line did not go through. Right. Okay, this seems... I'm suspicious. See if my loft will work. My loft will not work. That is not what I want. None of that is what I want. Okay. What in the heck is this? Okay. This construct an offset plane from this. Okay. Ah, I see. Come all the way out here. Right. By 20 millimeters. And then on there. Now, ha 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 ha. Now we can do this. Center diameter circle. It's going to be the same. Wait. Okay, that's not what I want. Why is the center... I don't understand why that center is there like that. Like what? What is going on here, guys? Okay, so I want... Basically... Can I make a line? Okay. I mean, I really want to just do loft. I want to do another arc that's offset up here, you know, with the same center as this. All right, look at this sketch right here. That's the center that I want right there. I want to give me that center. Offset plane from here, this direction, right? Okay. Good. I don't want the center of that plane. Okay. This is craziness, you guys. Unreal. All right. Here's what I'm going to do. I'm going to do sketch here. Okay. Going to do a new sketch right here. It's going to be 10. And then also... It's going to be 16. Then, okay, we're going to take this, finish sketch. We're going to extrude this. Excuse me, we're not going to do that. We're going to edit the sketch that we just made. That's which one? This one? The most recent one, yeah. We're going to bisect this with a line. Now we finish sketch. Now we extrude. We need to do this one. It's going to be pretty high up. It's going to go all the way up to, say, right there. Sure. Now, we're going to take this face. And I think we can just press pull the face, right? There we go. Perfect, huh? That's what we want. So that thing there. Now can we loft the surfaces? That'd be super cool, huh? Let's try it. Loft that to there. Woohoo! Heck yeah. That's exactly what we need. That's our part right there. So that'll be just glued in place, I think, once we get everything else there. And done. There we go. And that'll just go over where the power cord comes out. So we have 2 pieces. Okay. Save. Call this cord chimney. Huh? Cord chimney. Okay. So we've got our, go to 3D print. Send a 3D print utility? No. Uncheck that. Okay. This whole thing, okay, is going to be on the desktop. And it is going to be called what? Cord chimney. Save. And this big old thing, we're going to 3D print this as well. 3D print. Select all the things. Okay. And that's going to be called Power Box. All right, then. Let's save those things. We're going to go ahead and open up a slicer software here now so that we can get these things sliced. And you'll see that we have our file power box. It's a pretty big thing. It's a good thing our big Evo can do it. So lay it flat, excuse me there, right? And of course that'll require a bunch of supports. So we will standard, primary 5, strength medium, strength high. That's going to be the infill percentage. Heat on. That's the chamber heaters. Support everywhere. And then let's slice that and see what we get. So we're just slicing our file here, turning the STL into G-code. We've brought the STL into the Apex slicer, applied the defaults, and you can just sort of see it there in the top left still, compiling the G-code. So we'll see how long it takes us to print out this this box here. Let's see what it tells us. Okay, right. It's applying the fan adjustments at the particular Z height tweaks. There's another one. So the fan on the Evo, it's not able to go super high full power when the head is very close to the bed because it sort of backfires up against it and cools the head. And so there's some advanced features in the G-code that automate the fan power as a function of Z height. So it'll get stronger with the fan as it comes away from the bed. But if you just override that and, you know, use some other slicer and just do whatever you want, it's probably not going to work for you. So when we work with our Airwolf Evo here, we always want to just go ahead and use these default slicers settings in Apex and make sure it's up to date. Layers, our layer view right here. we'll see everything being built. It's a pretty long print, huh? 34 hours, 55 minutes. And that's going to take about half of a roll, of a 1 kilogram roll. So I guess we'll see what color I have a overabundance of and what that'll get printed in. And of course we have our other smaller parts that go on top there. We can go ahead and get those printed on our smaller printer relatively quickly and have those ready to go. So thanks for tuning in here, you guys. I'm going to go ahead and log off and get this print started. I may go ahead and stream the printing of it as well after I get set up with all the cameras moved everywhere, showing the printer and everything. So thanks for being here with me today, you guys, and I will see you later. Thanks. Bye-bye.